Hey class, Mr. Houston here. Today we're starting chapter 10, which is all about circles. The very first thing we're going to talk about in circles is the property of tangents when it comes to circles. Completely different than tangents that we were talking about in triangles. Well, not completely different, just a different setting for them. But the very first thing we're going to talk about is all the different parts of a circle. Okay, so some of the more common ones that you probably remember, you have the center. Remember, a diameter is a line that touches both sides of a circle and goes through the center. A radius is from the center out to the side of the circle. A chord is a line that touches two edges of the circle but doesn't go through the center. So make sure the chord doesn't touch the center. If it touches the center, that'd be a diameter. Okay. Now, some of the more uncommon things that we're going to get into here are the secant and the tangent. Okay, so a secant, it's kind of like a chord, but it's a line. It's a line that extends through the circle, touching the circle in two different places. That is a secant. A tangent will touch the circle in exactly one spot, and that one spot that it touches the circle is known as the point of tangency. So a secant intersects the circle at 2 points. A tangent intersects at 1 point, that point being the point of tangency. So we'll talk more and more about this as we go through, but for the most part here, let's just talk about identifying special segments and lines. All right, so the first thing we're looking at is AC. So we're talking from here to here. That goes halfway through the circle. It includes the center. This would be known as a diameter. I'm sorry, this is not known as a diameter. You can tell it's Monday morning. That would be known as a radius. It only goes halfway through, so that makes it a radius. Now line AB goes all the way through, touches the center. That would be a diameter. DE goes through here, and it looks like it touches the circle at point B. So if it touches the circle just once, that makes it a tangent. Now AE goes through the circle, and it touches both at A and G. It touches it twice, making it a secant. So those are just identifying some of the special segments that we see in circles. So we're just going to do a lot of things with circles here. Example 2 here, we're going to use the diagram to find the given lengths. We're not going to do anything special. We're just going to count because we are in a coordinate plane, so we can just count the units. It doesn't say that each unit is a certain length. It just wants us to find the given length. So the first thing is they want the radius of A. So radius, remember, is just from the outer circle into the center. So that's going to be 1, 2, and 3. So this would be 3 units. Okay, the diameter of A. So if we know the radius is 3 units, the diameter is always double that, so we know it's 6 units. Now they want the radius of B. Again, you can just count from the edge in 2 units. And the diameter of B, in this case, will be 4 units. So you just have to count the lengths. No, nothing special about it here. They just want you to understand that you're going to have to count to find some of the lengths of these different segments that we'll be using. Alright, so this is just kind of a little informational graph here. Just showing you that when you have 2 intersecting circles, they have 2 points of intersection. This is kind of the one we're going to deal with, and that's 1 point of intersection. They're called tangent circles. And then you have no points of intersection that look like that. Okay, so our main focus is going to be here and trying to find tangent lines to both circles. Okay, let's go ahead and flip your note over. So, first question is, after that is going to be tell how many tangents the circles have and draw them. So the easiest thing to do is to draw all the lines that they would have in common. Remember, tangent means that they're only going to intersect each circle at one point. They're going to touch the circle at one point. So for letter A, one of the easier ones would be this one right here, because they'd intersect here and here. Therefore, they'd have one here. Now the harder ones to see, because there are two more here, would be the one that goes, and I know I'm horrible at drawing, but it would kind of come right through there, which means that there would also be one that goes right through there. So this one actually has 4 common tangents. Okay. As far as example B, again, you'd have this one here and this one here. I think there might be one right through here that maybe only touches both of them right at the same spot. But this one would have 3 points of tangency. And then the last one, just your traditional 2, one here and one here. All right, so what are we going to do with these tangents? Well, if a line is tangent to a circle, then it is perpendicular to the radius of the circle. Okay, so what they want you to understand is when you have that line of tangency, the radius is perpendicular to that line of tangency, so it creates a right angle. So what do you think we're going to do with that? Well, we're going to use it to try and verify if it is a tangent to a circle. And how do we do that? Our trusty old friend a squared plus b squared equals c squared, or as we like to call it, Pythagorean theorem. Okay? All right, so how do we do that? Well, remember, we have the radius out here. This is our line of tangency. All right, so I'm going to go ahead and draw that right angle. Draw that right angle in there, right here. So that makes this my hypotenuse, this is my C, this is my A, this is my B. So 35 squared plus 12 squared equals 37 squared. So hopefully you have a calculator nearby that is handy that you can use to square all of these out. Remember, just like the last chapter test that we took, we're just trying to determine if they are equal to each other. So 35 squared is 1,225. 12 squared is 144. And 37 squared is 1,369. When we take 1,225 plus 144, we get 1,369. They equal each other. Therefore, the answer to this is yes. ST is tangent to that circle. Okay? So obviously they're going to have us put that into play and put it into use. They want us to find r here for the radius, and we're going to do that again using a squared plus b squared equals c squared. Let me see here. So Pythagorean theorem. Okay, so this is my tangent line. This is my radius. So there's my right angle, making this is my C, A, and B. So my A is 80 squared plus r squared equals C, which is the entire 50 plus r quantity squared. Okay, so 80 squared is 6,400 plus r squared. A little side note over here, to do 50 plus r squared, we're going to do 50 plus r times 50 plus r. 50 times 50 will give us 2,500. 50 times r is 50r. R times 50 is another 50r. And then r times r is r squared. So when we do that, we will end up with 2,500 plus 100r plus r squared. Okay, so I'm going to subtract r squared on both sides. Those will cancel out. I'm going to have 6,400 equal to 2,500 plus 100r. subtract 2,500 on both sides. That is going to get me 3,900 equal to 100r. Divide by 100, divide by 100. R in this case will equal 39. Okay? Lot of work going on there. That's probably one of the more difficult ones we'll encounter, but you know we'll do more work on that. All right, last theorem we're going to talk about here. Tangent segments from a common external point are congruent. So what they're saying here is they share this common point out here called S. They're both tangent, which makes them now congruent. So we're going to use that to try and determine lengths of certain sides. So we have this point in common R. We have a tangent here, meaning these are congruent, kind of like an isosceles triangle. And so we set them equal to each other. 3x plus 4 equals 28. Subtract 4 on both sides. 3x equals 24. Divide by 3. Divide by 3. X equals 8. All right, so that's your introduction to circles and tangents. A lot going on there. I do anticipate a lot of questions, so make sure you have them. If you do, bring them with you to class, and we'll see you then.